What did the digital clock say to the grandfather clock? Look, Grandpa, no hands! Hey guys, so we're on to number 4 on our forces, balanced versus unbalanced worksheet. Let's go ahead and take a look. A model rocket with a mass of 0.65 kilograms is fired straight up into the air. At the end of its 2.7 second burn, it is at a height of 105 meters. What force is provided by the rocket's engines? Now, this is a fun one. We don't have F, we don't have A. We're going to have to use our handy dandy kinematic formulas. So let's make a variable list. S, XI, VI, VF, AT, F net, and mass. Now, do we have any forces other than F net in this equation? It does not appear so. I've got one object moving, being driven by a force that is present on that object. So I only really have to track the one F net. So let's go ahead and start to solve this by putting in our variables. We have a 0.65 kilograms for our mass. And we have 2.7 seconds for a burn time. And we have 105 meters for a maximum height. I should say 105 meters at the end of its burn time. That's not necessarily its maximum height. That's the height it reaches when it finishes accelerating. That's going to be important because what is our XI? 0. Easy, breezy, beautiful, cover girl. Our VI is also going to be 0 because before this rocket blasts off, it is sitting on a pad, not moving at all. So, we don't know our VF. We don't need to know our VF. We can continue this problem after the fact and determine a VF. We could even determine a maximum height of the rocket, but we're not gonna. We don't care. We just want to know the force provided by the rocket's engine. So first, before I can find force, because what is force? What is it equal to? MA. I have M, I need A. I am missing A, so I need to find A some way, somehow. My VI is 0, and my VF is unknown. So my acceleration equation is useless to me here. I cannot use it. It will not do anything for me. I can pretend that it's doing something, but it will not, and I will not get the right answer. So I need to use my S equation. And as in our previous two problems, our XI and our VI are both 0, so we can get rid of them. S is going to equal 1/2 AT squared. Beautiful. It's so simple. So S is 105. 1/2 A and T is 2.7 squared. So right off the bat, I'm going to move the numbers I have to the other side of the equation, get A by itself, and then I will have found my acceleration. So we're going to do 105 times 2 to get rid of this. And then we are going to square 2.7, and we're going to divide whatever that result is by it. So 105 times 2 is 210, then A and 2.7 squared. 2.7 squared is 7.29. And we're going to divide both sides by 7.29. That's going to get us 28.81 meters per second squared. So our acceleration is equal to 28.81 meters per second squared. Now that I have my acceleration, I can find my net force. So we're going to go ahead and calculate that. My mass is 0.65 kilograms times my acceleration of 28.81 meters per second squared is going to get me 18.72 newtons. Putting that in my variable list, boxing it up. Wonderful.